Hello, everyone. Welcome to our webinar. We'll get started in just a couple minutes. All right, let's go ahead and get started. Welcome to our webinar today. My name is Justin D'Souza. I'm a quantitative specialist here at Statistics Solutions. During today's webinar, we are going to discuss SPSS data cleaning and management steps. So I'm going to go through the entire presentation first, and if you have any questions, you can type those into the chat box or the question and answer box. My colleague Brittany will be assisting with questions during the webinar, primarily pertaining to services that our company provides or links for resources. At the end of the webinar, I will go through the more specific questions about the presentation today. So yeah, just let us know if you have any questions. And we will send everyone a copy of the webinar as well as a copy of the PowerPoint. So today we'll start out with a description of the services that our company Statistics Solutions provides. Then we will dive into today's topic, which will be covering SPSS data cleaning and management. I will be going through a sample spreadsheet in SPSS. We'll conclude with a summary and a question and answer session at the end of the webinar. Our company, Statistics Solutions, provides assistance with every part of the dissertation journey. So no matter if you're at the topic development stage and trying to figure out a gap in the literature or a theoretical framework, the way our company works is we will assign both a methodologist to you and we'll assign a literature review specialist. So we have both quantitative and qualitative specialists. So depending on where you are in the process, if you hit a roadblock, just let us know and we can provide some assistance for you to get you over that hurdle. We help with the topic development, prospectuses, or concept papers, depending on which college you go to. The proposal chapters, which usually includes the introduction, literature review, and methodology. So here we can help you frame a purpose statement and problem statement, help you select a theoretical framework, formulate research questions and hypotheses, determine what research design you need to use, pinpoint quantitative and qualitative approaches, or even potentially a mixed methods approach. Then in the methodology specifically, there are data analysis plans that we can help with, so we can figure out specifically what statistical analyses we need to use to address your research questions. We can help you pinpoint the best survey instruments to use, so we can help you find both a reliable and valid survey instrument. We can help with IRB forms, data entry templates. We have our own SurveyMonkey account, so we can help you host a survey online. Then once you've completed your proposal chapters, essentially, we conclude with the results chapters, the discussion, PowerPoints for defense, and we can help you take your dissertation and condense it for a journal publication. So if you have any questions about the services that we provide, please give us a call here at 727-442-4290. On this slide, I have a couple hyperlinks that will take you to both the past webinars we've done. So we have recordings of those webinars as well as upcoming webinars we'll be doing in the future. All right, so diving into the topic for today, what do you do when you first obtain your spreadsheet? SPSS. Perhaps you've downloaded it from Qualtrics or SurveyMonkey, and you're wondering, what do I do next? How do I clean the data? Or maybe you've entered it manually into Excel or SPSS. You did paper surveys and you've manually entered the data in. What are the next steps? So the first thing you want to do is, and this is strictly if you're doing a quantitative survey, or even if you're using archival data, a lot of the same process steps will apply. So the first thing you want to do is add an ID variable so you can quickly identify each participant in your survey. And I will show you an example in SPSS. So throughout the data analysis process, you're going to be sorting your data in a different order. You might be looking for outliers, you might be searching for missing responses. The most efficient way to do this is by sorting columns in different orders. So if you ever want to go back to the original order, you can just sort this ID column that you create first. Then you want to name all your variables of interest. So maybe you have a demographic questionnaire that collects gender, age, ethnicity, education level. So you want to name those variables. And you can use Excel to quickly autofill variables, or you can use it to even make the ID variable for the first step up here. And then one of the most important steps, I would say, is saving often. Every time you make a major adjustment to the spreadsheet, you will want to save the spreadsheet again. You want to create a new copy. The reason for this being, if you ever want to go back to a particular step, you can quickly do that through a saved spreadsheet that you've created. So let's take a look at a raw spreadsheet here. Okay, so this is a raw data set that I extracted from SurveyMonkey. I made no manipulations to this data. This survey was measuring 3 components. It used 3 previously validated surveys, which was the leadership effectiveness inventory. I'll expand these questions here so you can see them. So it started out with only one demographic question, so years of service in a particular job. And then we have 7 items to measure leadership effectiveness. We have 5 items to measure job satisfaction. And we have 5 items to measure organizational performance. So when you first receive the spreadsheet, something you want to do is just quickly eyeball or missing data. So we can see that we have a participant here who just did not respond to anything. They may have provided consent early on, but then they just dropped out after that. So we can note that potentially some people need to come out. We can see people who responded to a majority of the survey, but they missed an item here and there. And another thing to note is that we have a combination of both numeric data. So these surveys were all Likert scale in format, meaning it was like strongly agree down to strongly disagree. So we have a combination of numeric data, and then we have questions that came out in string format. String format is essentially words or letters. So we have a hybrid of both numeric and string. So that's something we will have to reconcile as we move forward. The first things we needed to do were add an ID column. I'm going to go over here, right-click, and insert a new variable. Let's give this variable a name, ID. And we can count how many people we have. So it looks like there are 91 participants. So what I'll do is I'll go into Excel. There's unfortunately not a quick way to do this in SPSS, as always baffled me, but in Excel, it's very easy. You just start your list, you highlight, and then you drag down. Okay, so do 91, not 92. Okay, so then we'll come up here, paste it. Okay, so now we have an ID column. And as I was saying before, this is really important because say I just choose to sort a different column now. If you right click on any column, you can sort it in ascending order. So that's often used to identify where there are missing cases. It's going to put the missing cases first when you sort in ascending order. And now you can see that the ID column is all in a different order. The participants have been jumbled together. So if I ever want to revert back to the original order, I can just right click the ID and sort in ascending order, and we are back to normal. So the next step I need to close that again. Okay. So the next step is naming your variables of interest. Okay, so all you need to do is go into variable view here. This is variable view, which has a list of all your different variables, all the survey items. And you'll see these are the variable names and these are the labels. So specifically what the question was asking, when you identify the variable name, you can't have spaces, you can't have sentences. You just want a quick phrase, a word or two to summarize what the variable is. So for instance, here we have years of service, no spaces. Next 7 items measured leadership effectiveness. So you could type them all out in SPSS, but it's kind of tedious. So you just type the first couple cell, and then you just drag down. So highlight those 2. So capital letter there. And first 7 items, leadership effectiveness. Then the next 6 items were job satisfaction. And the last 5 items, organizational performance. Okay, so I can now just copy and paste these. Okay. So ultimately, step 1 is done. We've added an ID. We have named all the variables of interest. Let's now save the spreadsheet. So when I save it, I usually am very specific with what was done. Okay, so here we'll put today's date for one thing, 11/9, added ID variable, and named survey item. Okay, they seem tedious to be so descriptive, but trust me, it helps when you come back. Maybe your committee will ask you to go to a certain step in your data cleaning process. Maybe they want you to review how you check for outliers, or how did you account for missing responses. You can quickly jump to that step by identifying what you did for your step in data cleaning, right? Okay, so the next step is recoding. We want to recode the Likert scale items from string format, which are words, into numeric format. You also want to identify whether any survey items need to be reverse coded. So this is a concept that may be a little confusing if you are not familiar with it. I would suggest doing a Google search on it or watch a YouTube video. Essentially, reverse coding is used when you have negatively phrased items in your survey. So you might have a combination of positively phrased and negatively phrased items, which means you need to flip the Likert scale for the negatively phrased items. For example, as I look at the job satisfaction survey right here, the Likert scale went from 1 is strongly agree to 5 is strongly disagree. So if someone is satisfied with their job, we would hope that they have higher scores. We would hope that a 5 is strongly agree and a 1 is strongly disagree. So what we need to do is we need to find the positively phrased items and flip the Likert scale for those questions. So anything like this, my job responsibilities are clear. I'm provided with the tools and equipment I need to do my job. I'm given a proper orientation. I'm satisfied with my job security. And overall, I'm satisfied with my job. Actually, you know, all these are positively phrased. There are surveys sometimes where you'll have a negatively phrased item, and I'll show you how to reverse code. I actually don't think we need to do it in this case. So the next step is recoding from string to numeric. And that really just accounts for this part of the survey right here. Okay, so organizational performance went from strongly disagree up to strongly agree. We want to change this to a 1 to 5 Likert scale. And to do that, we'll go into transform and recode into same variables, okay? And I know I might be going fast through some of these steps. We are going to send a recording so you can rewatch and slow down and take notes. Okay, so we'll put all 5 of these items in the right box, and we need to identify the old and new values. Okay, so I strongly disagree. What I'm going to do is copy strongly disagree and paste it right here. That's our old value. The new value is going to be a 1. So we're changing that to a 1. A disagree becomes a 2. Neither agree nor disagree becomes 3. Agree becomes a 4. And strongly agree becomes a 5. Okay, there are 2 options now for almost everything in SPSS. You can either click OK to run the command, or you can click paste. I like to click paste because it presents syntax. Okay, when you click paste, it's going to give you the syntax file, which allows a second user to replicate whatever you're doing. Okay, so we can see this code right here is changing the words to numbers. So all you have to do to run this code is highlight, and we can see it happen in real time here. So I'll split the screen. So you just have to highlight the code and click this green arrow. So look at this section right here. As I click the green arrow, it's going to change to numbers. Okay, so now we need to change the variable type. These are no longer string because we have numbers, so we need to tell SPSS, this is all numeric data, not string. Okay, the next step was checking for reverse coding. So what we'll do for this one is all these questions for job satisfaction are positively phrased, but the Likert scale is inverted. A 1 needs to be strongly disagree and a 5 needs to be strongly agree. So it's actually a very similar command that you do. Instead of recode into same variables, when I reverse code, I often do recode into different variables. Okay, just so you can retain your original coding. So move all of these over here, and then we have to give them a name or a new name. So job satisfaction 1 reverse. Here's 2. Okay, and job satisfaction went from 1 to 5. We'll go into old and new values here, and we need to put that a 1, which was strongly agree, needs to now be a 5. 2 needs to be a 4. 3 stays the same. 4 becomes a 2, and a 5 becomes a 1. So as you put all the options in, you should see it go up the ladder 1 through 5 and down the ladder 5 through 1. You don't actually need to put the 3 to 3. It's kind of redundant, but I like to include it so you can see the entire Likert scale. So again, I'll click paste. Now we have syntax for this. You can put notes in your syntax because right now it kind of looks like a different language. So if you just put an asterisk right here, you can say that this was recoding from string to numeric. And this one was for reverse coding of satisfaction. So if we highlight this code and click the green arrow, this is going to create 6 new variables. So now we have the original job satisfaction, but we also have the reverse coded job satisfaction at the bottom. And we want to assign values. So right here, we'll say a 1 is now strongly disagree. And so you can just do 1 and then copy and paste the rest. This is actually the same for organizational performance. So I'll just copy and paste that right here. And that is it for our second step of data cleaning. So we recoded from Likert to numeric, and then we reverse coded. So now let's save again. All right. The next step is looking at missing responses. So there are many schools of thought on how to account for missing data. It really depends on your reviewer, I would say, in your school. They might have a preference. So there are complicated ways to do it, and there are less complicated ways. I prefer kind of a middle approach, something that's not too easy and not too difficult. So you can choose to use imputation. You can just leave the missing responses in, and SPSS will automatically do list-wise deletion and account for missing data. So if someone misses even one survey item, SPSS will exclude that person from all the analyses. You can use imputation, which is replacing the missing values through regression models. So that's more of a complicated approach. The way I'll show you today is replacing missing values with the average. Okay, so you can take the average of a column and replace any missing cells with what the average mean is. Another thing to keep in mind is you probably run a power analysis in your methodology chapter. So you need to figure out what is the minimum sample size you need to keep in your study. You don't want to delete people if it's going to put you below that power analysis, because then you're going to reduce the validity of your findings. Okay, so as we go into data view here, and we looked at this at the very beginning, we did see there was a missing case, someone who just not respond to anything. This individual needs to come out because we don't have any usable data for them. So I would just take that person out. A quick way to identify missing cases, and we did do this before, is just right-clicking a column and sorting in ascending order. So this is going to quickly identify who's missing any surveys, and there are 5 people here, is what it looks like, who did not respond to any survey question besides the consent item. Okay. So we can take these individuals out. Before I do that, I'm going to save one more time. I'm going to just save a copy and identify the sample size we have right now. So we'll just put over here, n equals 91, full sample. And we're going to remove these people here. Now we are down to 86. Okay. So we've saved a new copy with the missing cases taken out. 5 were removed. The next step we can do is look at people who missed an item here and there. So the best way to handle this, let me move this towards the end. So as I said, you can use mean imputation or mean replacement to swap any missing cells with the average. So for instance, let's find the case, this individual right here. What SPSS will do is it'll take an average of this entire column and then put the mean in for this value right here. To do this, you go to transform and replace missing values. This window now pops up and we'll just put everything in there. Okay, so we'll put, we don't need to put job satisfaction twice. We have the reverse coded items and we have the original. I'm just going to put the reverse coded ones. We don't need to do it twice. So we'll put everything over in this right box. And the default option is taking a series mean. So we can paste the syntax. Now we have syntax code for replacing values with the average. So I can highlight this code and click the green arrow. This is going to create additional variables. So you'll see there's a duplicate for everything now. Leadership effectiveness 1 is the original. And down here, we have leadership effectiveness 1 underscore 1, where you see the underscore 1. These have missing values replaced with the average. So you'll see that there are no missing cases now. Everybody has a survey response, which is great. Okay, so we can take these labels now, fill them in here. We don't want series mean leadership effectiveness. It's not very descriptive for what we need. So we'll just put in the correct labels. Okay, so now when you're doing the data analysis, you have to be very careful that you're using only these items below. You could just delete everything above that to play it safe, but I tend not to do that. I like to keep the original variables intact, just in case. I think that's it for this step. Okay, so we replace missing values. Keep the sample size in there as well, n equals 86. The next step is creating composite scores. So this is really the final step here. We need to take an average or a sum of the items in the survey. So instead of having 7 leadership effectiveness items, we want to have one score that represents leadership effectiveness. We want one score that represents job satisfaction, and we want one score for organizational performance. So to do this, we'll go to transform and compute variable. Now you'll have to look at the scoring instructions. I should have mentioned this before, is when you are using a previously validated survey, you want to look at the scoring instructions for that survey. It may be online, it may be a public document that is provided, or you can reach out to the author themselves. You can look on LinkedIn, you can find their email address usually on LinkedIn. But reach out for scoring instructions because there may be very specific steps that you need to do. Some surveys you take an average, some surveys you take a sum of all the items. In the scoring instructions, it will also identify if you need to reverse code items. So that's really an important thing as well. So to take a composite score here, for job satisfaction first, I'll give it a name, job satisfaction overall. For this particular survey, and for all 3 of them actually, you take an average of the survey items. So we will take a mean. And so to do this, you just select job satisfaction. And you select, what you can do is you can just put commas, the next item, comma, next item, which isn't too bad when you have only 6 items, but you can also do the first one, write the word to, and then indicate the last one. So average or mean of job satisfaction 1 through 6. Click paste, and I'll go ahead and do the other 2, and we can run them. Leadership effectiveness. And also, yeah, make sure that you use the items at the bottom. Remember, the ones at the top half are not accounting for missing data. So leadership effectiveness 1 through 7. And finally, we have organizational performance. Okay, so we can take a look at the syntax file here. Here we are creating composite scores for variables of interest. I did do these slightly out of order. So leadership effectiveness should have gone first. Doesn't really matter, but just kind of consistent. Okay, so then we can highlight the code and click the green arrow. And now you'll see we have 3 new variables of interest. Everyone has a leadership effectiveness score. And see how it changes from just a Likert scale. It was 1 through 5 before, and now we have decimals as possibilities. That's usually a good indication that we've done it correctly. And everybody has a score for all 3 variables. The next step is identifying if there are outliers. This is usually a data cleaning step. And there are many ways to check for outliers. You can use box plots, which is one way to do it. So first, let's save. And we'll just call this creating composite scores. 86. So let me first show you the box plot method. The way to do this, you go to Descriptive Statistics and Explore. And then you put in the 3 variables at the bottom into this box here. And you click OK. And so it's running right now. You can see at the bottom, it might take 20 seconds to run. Okay. Here are the box plots. You can see right here. And if there are outliers in the box plots, you will see a point extending beyond the whisker. So here's the box and here's the whisker. If there's a point outside of that, then you have an outlying case, but we don't have any. We don't have any visually, at least, with any of the 3 variables of interest. So we're in good shape visually for outliers. There are other ways to check for outliers. One of those being looking at Z-scores. So Z-scores, that's what I described right here. According to this citation by Tabachnik and Fidel, they standardize their scores. And if the Z-score or standardized value exceeds this many standard deviations from your average, then you have an outlier. We can standardize the 3 scores. And to do that, you go to Analyze, Descriptive Statistics, and Descriptives. And we'll put in the 3 variables of interest over here. And the most important step right here is check marking this box. So save standardized values as variables. Once I click OK, you will see 3 new variables now, and they have a Z in front of them. So we have leadership effectiveness, the original, and then we have the Z-score for leadership effectiveness right here. Likewise for job satisfaction and organizational performance. So according to this citation, if any of the Z-scores exceed positive 3.29 or are lower than negative 3.29, then we have outliers and potentially remove those cases. Quick way to check for those is by sorting these columns in ascending and descending order. So if I right click and sort ascending, we can see the lowest Z-score is negative 0.97. So that's not below negative 3.29. And if I sort descending, the highest Z-score I have is 2.79, which is not greater than 3.29. So we have no outliers there. Let's do the same thing. So 3.29 is our threshold. It looks like we are within it for all 3 variables. So no outliers were identified. Save a new spreadsheet, specify what was checked. The final step here is not really data management, I would say, or data cleaning, but it's one of the first things you do for data analysis. So if you ever use a previously validated survey that happens to use Likert scale questions, you want to check for reliability. Reliability is usually assessed with Cronbach alpha. So Cronbach alpha is making sure that participants are consistent in how they respond to the survey. If someone says, I'm agreeable on a survey question, then you would hope that they show consistency and they are agreeable on the other questions. You don't want them jumping around between strongly agree, neutral, and agree. You want a level of consistency in the responses. So that's what Cronbach alpha checks. And to do that, you have to analyze, scale, reliability analysis. And here, I'll just show you leadership effectiveness to illustrate. So we'll select the items at the bottom. Leadership effectiveness, 1 through 7. And then you just click OK. So the cutoffs for this, you would hope that your Cronbach alpha is greater than 0.7. And we can see it is right here. It's 0.965. Anything above a 0.7 is acceptable in the social science. Have good reliability. And this I would say is essentially the final spreadsheet. So just final step I do is I sort the ID column in ascending order again. And I will save a final copy here. Okay, so we'll just put final. And the sample size, I always put the sample size. I think that's really important just to keep a running record. Remember, we started with, I believe it was 91 here. Now we're at 86. So that's probably something you have to discuss in your results chapter. You have to talk about there being 91 people who provided consent. 5 came out for not responding to any part of the questionnaire. And mean replacement was used to replace the missing values that remained. Okay, so the next steps are then using descriptive statistics to examine your demographics. So maybe you collected data for gender, ethnicity, education level, things like that. You want to run frequencies and percentages on that data. So this sample data did not have demographics besides years of experience. Then you want to verify the assumptions of your analyses. So when you do a parametric analysis like a t-test or a regression or an ANOVA, there are very specific assumptions you have to verify. Things like normality, removing for outliers is one of them. That's what we looked at today. Linearity or homogeneity of variance. Those are all assumptions you may have to verify before diving into the key analysis. And then once you've checked your assumptions, you can address your research questions with inferential analysis. So thanks for joining us today. I'll now open the webinar for any questions. So you can type those into the chat box or the question and answer box. We will be sending everyone a copy of the recording and the PowerPoint, most likely tomorrow. And let us know if you have any questions. If you've hit a roadblock in your dissertation, maybe you're stuck at a certain part in the proposal, maybe you need help formulating your research questions or developing your data analysis plan, crunching your numbers. We have specialists here who can help you out. So just let us know. You can give us a call at 727-442-4290, or you can email us at info@statisticsolutions.com. All righty. We have any questions? You go through an example of testing for normality. Absolutely. Okay, so similar to outlying values, there are many ways to check for normality. It depends what reference you use. There are visual ways of looking at it, and there are statistical ways of looking at it. So I'll show you the visual one first. So we have our variables of interest down here. These 3 factors. So what you can do is go to Analyze, Descriptive Statistics, and Explore. It's actually the same menu that we used for outlying values using box plots. Then you click on plots and you can check mark this box here, normality plots with tests. Continue and click OK. So there are two ways, actually three ways, in just that output that are going to check for normality. So statistically, what is run here is a Kolmogorov-Smirnov test and a Shapiro-Wilk test. The math for these is actually pretty similar. So what you want to look at is significance. What these tests are doing is it's checking to see, is your data significantly different than a bell-shaped curve? Okay, so if we have a significant p-value, meaning a p-value below 0.05, that means that your data is significantly different than a perfect L-shaped curve, which is the case for both the Kolmogorov-Smirnov and Shapiro-Wilk tests. So this can happen when you have a relatively small sample size. 86 isn't actually too small, but as you increase in the sample size, you may be more likely to find non-significance. These are very sensitive tests. Okay, so you're going to see significance a lot. So based on these findings, the data are significantly different than a bell-shaped curve. You can discuss with your committee which one to present, Kolmogorov-Smirnov or Shapiro-Wilk. You usually don't need both. Then we can look at normal plots. We have a normal QQ plot. This is a visual way of testing for normality, and we can see that ideally, for the assumption to be met, the data needs to fall on this diagonal black line. And your data are these little blue points. So we can see that it actually does follow the line relatively closely, which is great. So that's why you can you can receive contradictory findings between doing it statistically and checking for normality visually. The next one also looks pretty good for job satisfaction. And the final one for organizational performance also looks pretty good. So the diagrams seem to indicate that the data are approximately normal in distribution, but the 3 tests we ran for each variable do not show such good findings. So that's where you have to make an executive decision, because right now I would say these are contradictory. Visually, it looks good. Statistically, with the numbers, normality doesn't look so good. I tend to use the statistics because looking at plots is more of a subjective decision, whereas these numbers tell you definitively, does the data appear normal or not? So I would go with these tests as opposed to normal QQ. All right, do you have any questions about that? And do we have any other questions? It looks like Brittany provided some hyperlinks in the chat, free resources at our company website, as well as the webinar archive, and a link in which you can schedule consultations. Yes, so we have the question of follow-up to the normality test. This is a rare time in statistics where you do not want to see significance. You want to see a p-value greater than 0.05. Okay, do we have any other questions? Any questions about the presentation or the services that we provide? All right, I'll stay on for a couple more minutes. 3 types of assumption testing. Are you talking about normality specifically? So there's the Kolmogorovs. There's actually 4 that I'm aware of for normality specifically. So there's the Kolmogorov-Smirnov test. That's 1. Shapiro-Wilk is 2. Normal QQ plots is 3. And then you have, you can even look at histograms. So if you go into descriptive statistics and frequencies, and then put in your variables of interest into the right box, and under charts, select histograms. You don't have to check mark this box. This will generate 3 histograms, and we can see visually the data does not appear to be normal. Okay, so we have a skewed distribution to the right for leadership effectiveness. Job satisfaction looks a little bit better. We have a peak right here in the middle, but it is also skewed to the left. Likewise for organizational performance, it's also skewed to the left. And let me go back to the presentation about assumptions. I may have misspoke. 3 types of assumption testing. So this is where I talked about assumptions. There are many different assumptions. It depends on what analysis you're running. So a good place to look for that is if you go, for instance, let's say we're doing a t-test. Okay, independent sample t-test. If you type that and then put in statistics layered, it will bring up this hyperlink, and you can do this for any test. Statistics layered after it in Google. And you'll see there's an assumption section in here. It tells you specifically what assumptions need to be verified for a t-test. Every analysis has different assumptions. So it doesn't have 3 or 4 necessarily. It may have more. So we can see this one has 6. There's 6 assumptions you should check for when doing a t-test. Okay. Does that make sense? Yeah, sure thing. All right, I'll stay on for a couple more minutes if we have any final questions. We can take a look at the upcoming webinars. Okay, this is the one I'll be doing next week, how to conduct and interpret tests of differences, which is actually, this is one of those. So we were just looking at a t-test and what assumptions you need to verify. That is one of the tests we'll be looking at. And then the following day, my colleague Tom will be doing a literature review webinar. Then we have an entire qualitative methodology webinar, which will be done by my colleague Rachel. We have a quantitative methodology webinar, which will be done by my colleague David. And then presenting quantitative results will also be done by David. Looks like we have another question. Can you go through how you would calculate Cronbach alpha for a Likert scale? Yeah, we did an example here for leadership effectiveness. So you need to make sure, for one thing, that your surveys all use a similar Likert scale format. Okay, so everything here for leadership effectiveness was a 1 through 5 Likert scale, from strongly agree down to strongly disagree. Then you go into analyze. You also need to make sure that you've accounted for reverse coding. So if there's anything that needed to be reverse coded, you need to take care of that before doing Cronbach alpha. So you'll go from analyze to scale to reliability analysis. This is what it looks like. You put in all the items that were comprised for that variable. So leadership effectiveness, you put in every single item, and then you give it a name. Leadership effectiveness is the construct, and then you click OK. And we can see the Cronbach alpha, how many items were in that survey, 7 items, and the Cronbach alpha was 0.965. Okay, so anything above a 0.7 is acceptable. Okay, we have any other questions? Yeah, you're welcome. All right, thank you for joining, everyone. I'm going to close the webinar now. We will send you a copy of the recording. Let us know if you have any questions. If you need help with your dissertation, or if you need help crunching numbers, just let us know. Join us for the future webinars, and look forward to seeing you again. Have a great evening.